So for this, we're going to take some time to go over the two proofs from the review packet. So the first one is going to be that RS and TV bisect each other at point X, and we want to prove that two lines are parallel. So the first things first is we're going to work with our givens. So RS and TV bisect each other. There's our givens. Now because it says each other, we can work with both of them at the same time. So then in step 2, we're going to do Tx is congruent to Vx, and Rx is congruent to Sx. And the reason for that is going to be a bisector divides a segment into two congruent segments. Now our third step here, we're going to work with our vertical angles and put 1 and 2. So angle 1 is congruent to angle 2. Step 3, vertical angles are congruent. And then we have enough information, so our triangles are congruent. Triangle TRX is congruent to triangle VSX, and our pattern here is side, angle, side. Now in order to prove that two lines are parallel, we first need to prove that we have some alternate interior or corresponding angles that are congruent. So a couple different options of what you could grab. I'm going to do T and V, so I'll call them 3 and 4. You could also grab R and S. Angle 3 is congruent to angle 4. That's going to be CPCTC. And since we have angles that are in alternate interior position that are congruent, then we have parallel lines. TR is parallel to SV. Congruent, alternate interior angles form parallel lines. Okay, so that's our first proof. Let's move to our second one. Our second one is definitely more challenging. So as we go here to make our chart, there's going to be I wouldn't say anything necessarily new in here, but there's definitely going to be some extensions that we have to talk about. So for our first piece here, will be statement and reason, and then we'll list out all of our givens. So FG is congruent to EG, and then angle EGC is congruent to angle FGC. So it seems to be that everything they're giving us here is working with those top left and right triangles. So to add to that then and get them to be congruent, we're going to do CG is congruent to CG. That's going to be our reflexive property of congruence. And then right away we have two triangles that are congruent. Triangle CEG is congruent to triangle CFG, and we already have side, angle, side. Then from there, we need to get all of AC is congruent to all of CB. So I'm going to start by getting what I can here in the beginning, which is that I can get that CE is congruent to CF by CPCTC. So I can get the top parts of the triangle, of those sides, to be congruent, but now I've got to work towards the bottom. All right, and this is also one of those rare times where we end up having to CPCTC two different things. The reason is we want to start to work in these little triangles that kind of form the bow tie. So in that case, I'm going to CPCTC those two angles at E and F, because then we can use supplements to get them into the bottom bow tie type triangle. So those are also congruent by CPCTC. Then I'm going to work with our supplement piece. So then I will call 3 and 4. Remember, supplements take 2 steps. So angle 1 is supplementary to angle 3. Angle 2 going to be supplementary to angle 4. And again, that's true because they are adjacent angles on a line. And then we can say in step 7 that angle 3 is congruent to angle 4 because congruent angles have congruent supplements. All right. So now if we look in those bow tie triangles, we have angle side and angle side. Okay, the side is EG and FG. That's a carryover from the very beginning. And I'm not going to put congruency marks in here. But we have our vertical angles at 5 and 6. I'm not putting congruency marks in because it's getting a little crowded in there. So angle 5 is congruent to angle 6. Vertical angles are congruent. And now I have enough information to prove that those two triangles are congruent. So I have triangle AEG is congruent to triangle BFG. And my reason there is going to be angle, side, angle. And now what I can do is I can CPCTC the very bottom parts of those sides that I need. So AE is congruent to BF, CPCTC. And now we can just finish this up. We have 2 more steps that we want to work with here. Just want to extend my line a little bit. So for our last 2 steps, we are going to be step 11. AE plus EC. So we're going to take the 2 parts of the left that are going to make the whole thing, and we're going to set it congruent to BF plus FC. So we've proved that the top 2 are congruent and the bottom 2 are congruent, and now we want to add them together to get the whole thing. And that's going to be our addition postulate. I'll write that a little bit neater here. That's the addition postulate. And then the last piece to finish this up is going to be that now we're going to substitute in the whole side. AC is congruent to BC, and that's going to be our substitution piece and our prove statement. Okay, so a little bit different in the fact that we had to do a double CPCTC at one point, but it was still a double congruence, and then we finished with an addition, even though I know that's normally in the middle of the proof. But if you understand this and you know how to repeat this piece, then you should be good with all of our proofs.